Hello everyone, I'm Federico Spolaore and I will present the project Roncalli. Roncalli is the name of the company, so there is no NDA, and MS mid-size CNC mill. So first of all, what is CNC machining? CNC machining is a mechanical process that is used for producing mechanical components in metal, aluminum, steel, or plastic, or technoplastic like PTFA or other materials. And these components are produced sending a file to a machine, and the tool is following a path in order to create the components. So where the idea starts? In the market there are three categories of machines. Desktop size that are only used for academical teaching. They are not used for production. They are not rigid enough to perform good tolerances. Then normal size, the most common in the market. It has an average size of 1 meter. 1 meter is the size of the component that can be machined. And then you have giant size. They can range from 2 meter to 20 meter. Following the 3 arrow, more I go to a big size, I have an increase of cost. I have an increase of precision because precision is tightly related to weight, and more big is more weight I have. And then the size, of course. We identified a gap in the market between desktop size and normal size. In this graphic, we represented the position. On the x-axis, the value of the new machine, and on y, the average dimension. Why there is this gap? The producer of machines, they have to sell the machine. So a machine has to be beautiful, has to be shiny, painted with metallic color, with the logo engraved on it, and then they want to implement a lot of features. For example, the file, they have many, I don't know, 80% of the market is using .g code. Other machine, they are using Heidenand control or Fanuc control. And they want to implement all of this because they have to sell the machine, and the machine has to be effective in all possible situations. But this is not our target. Our mission is to identify a geographic area. In that geographic area, to identify which is the most common size of component who is produced. For example, 80% of component is below 50 centimeter. Okay, our target is 50 centimeter. Why this? Because this is the value, and most of the company, they use a 3-meter machine to produce 10 centimeter components for the 80% of working hours. So I am working much below the performance of the machine. So the idea is to design, project and develop a machine that has to be effective for that size. So how is the company organized? There is me, who I am the project manager of this machine. And then I have one girl who is doing market research to find all the competitor, all the data of the competitor. And then she has to give me precise value, like this is X, Y, Z. This is the value we need. And then I have 2 engineers. One is doing the design, and one is following the order of all material, production, assembly, relationship with supplier of material, and so on. These 2 persons, they have to relate each other every step for what they do. For example, the designers say, okay, I did this choice, I need this material, I need the pig iron, cast iron, and then the head of production have to say, okay, for this material we need 2 weeks, 3 weeks, 3,000 euro, 5,000 euro, and the process is going on. Okay, the methodology is waterfall. We are small, and in a small company you cannot do otherwise because you have a low limited personnel and resources. It doesn't mean that it's not effective, because one of the focus is cost control. So this is the best methodology to cost control. Unless the previous task is not finished, we cannot go forward. The only thing is, let's say, hybrid, because if there is a design change request, we need to go back to design, order new material, assemble the modification again, and then go on. So let's make a review of what is the target and constraints. So the target is define precise machinable area, so x, y, z of the area who can be useful to produce a component, and this has to cover the 80% of possible components who are produced in this area. Then we have to design the machine with the most simple design that exists. We have to be focused of efficiency on the machine, and the machine has to be totally automatic. So there should not be someone who has to follow the machine, I don't know, during the shift or during the night. And then this is additional target. If we can provide to add in the future additional equipment. The constraint is the size of the machinable area. We don't have to go over this. The budget is 30,000 euro, split into 15,000 for development, so for design process, and 50,000 has to be the cost of purely the material and the assembly process. And the time schedule should be like 8 months. Okay, so principal stakeholder is already defined, because we want the machine reliable, so we choose the most common and the most used by everyone in this field, because they are reliable. It's very easy to find supplier and components, and we can change between one and the other. I mean, if I have 2 broken of them, I can make one from 2. So we divided in 3 levels. First level is a company where we buy, and also we have to get a relationship of co-design. So I have to ask them, what's your opinion about this, and that. Second, level 2 is just where you go and buy, or maybe you ask for a very low level consult. And level 3 is all the other personnel involved. There is a schedule where all the tasks, all the steps of the process have to go, and this is the number. It means working days. So 5 is 5 working days. 120 days is not. I'm not counting it with the Saturday and Sundays. Okay, now we are around, we passed the G. G was important milestone. It was after feasibility study. We decided, is this idea valid on the market, or is a bullshit? And it seems valid, so we are going on. At the moment, this is the current design. So the CAD file is ready. We implemented also the additional automatic tool changer, and it's going on. So I analyzed a little bit of risk. First risk is to start from a wrong value of machinable area, but I'm quite sure, because this value is been confirmed by person who is working in the industry from 30 years, and I ask them, in your life, what's the common size you machine? And they say like this. So value is correct. And the second point is to find a problem during assembly. So we need to go back to design again, spend more money, order more material, and go on with all the steps. So thank you, and that's it. Goodbye.